The Matterhorn, one of the most audacious cable car projects in Europe, is being built here.
This is not an off-the-rack product.
A mega construction site. Under the most difficult conditions. Humankind locked in battle with weather extremes.
The weather might change 6 times a day up here. First it gets hot, then the wind comes, then there's snow. It changes every hour.
Technically and logistically, this is a major feat. Heavy cargo is delivered by helicopter. A challenge for man and machine alike.
The cables are our biggest enemy.
It's a tightrope act. An extreme construction site at an altitude of more than 3,800 meters.
You have to look after yourself because everything's more strenuous.
A job in the midst of breathtaking scenery. The goal of these efforts, to connect Switzerland with Italy. Building a cable car at the foot of Klein Matterhorn, a once-in-a-century project in the Alps. The Matterhorn Glacier Ride 2. From Zermatt, the route leads up to a monumental natural backdrop. To the right is the Matterhorn, one of the most iconic mountains in Europe, aiming high on the highest construction site in Switzerland.
We are building on a mountain under specific climatic conditions. This isn't something you'd find in a book or in an official standard. You have to conduct wind measurements. You have to know the level of local snowfall. Geologically, too, you have to know what's going on here on the mountain.
So much for the theory, which is animated here. The route leads from Klein Matterhorn on the Swiss side down to the Testa Grigia Valley Station, located at nearly 3,500 meters above sea level in Italy. The goal is to build Europe's highest alpine cable car crossing.
We're building the station shorter because the mountain doesn't allow us to build large stations. We're making the stations less wide, so we need less space. All these factors play a part in making this project a success.
The foundations for the mountain station on Klein Matterhorn are at an altitude of 3,850 meters. The construction crane is erected by helicopter. Small excavators prepare the ground. The cable car station on Klein Matterhorn is being built here like a ledge carved into the mountain. A job for the specialists from Sterzing, Italy. It's considered one of the world's leading manufacturers of cableway systems. The experts are on board for the multi-generational project to construct the Matterhorn Alpine Crossing. The base camp for the cable car is here in South Tyrol too. This is where all of the construction components are pre-assembled in a kind of dry run, like a jigsaw puzzle, before they're taken up to the mountain to Zermatt. Technical manager Klaus Erharter inspects the pre-assembled rollers on the supporting structure.
The customer on the Matterhorn is very demanding. To Swiss people, this is the sacred mountain, so the best is barely good enough.
On Klein Matterhorn, at an altitude of more than 3,800 meters, every bolt has to be in place. That's why construction has to occur at the base camp here in Sterzing. Every cable car system is unique and has to be custom manufactured. Spanning 1.6 kilometers, the cableway will connect the Testa Grigia station with Klein Matterhorn without support towers. Precise positioning of the circulating rollers on the carrier station down to the millimeter is crucial.
The height setting for the synchronization has to be very precise, because only rubber tires are used to turn the gondola around for the return trip once it reaches the station. If the heights are not correct, then the gondola grinds through the conveyor tires and is not transported, and so on. Then there are repeated shutdowns, and of course those have to be prevented.
The individual components of the support sections are manufactured separately and then welded together.
Here we see a cross beam being automatically welded. Later on, this component will be installed in the station, where it will support the whole structure.
The robot's work on the various components is fully automatic.
Big, heavy components with a large welding volume are connected onto the system here. We can weld components with a dead weight of up to 10 metric tons.
The production line is almost fully automated. Special machinery does the milling for balancers for gondolas that arrive at the valley station. Water is used to cool the large milling machine during production to ensure clean results while preventing overheating. This process is constantly supervised on the monitor, but runs digitally and automatically.
We're a high-tech firm when it comes to mechanical engineering, milling and robot welders. And certainly additional steps will be taken in the future to ensure that we're even more mechanized.
The ergonomic and back-friendly crane does the heaviest lifting. A pair of rollers weighs nearly 100 kilograms. The milled grooves are greased for perfect lubrication before heading to the carrier system. Bolts fix the rollers in place.
We really do everything we can to ensure that the parts are properly pre-assembled when they arrive at the construction site.
Another pair of rollers is ready for processing. A brief discussion in the team before the pairs of rollers are placed on the carrier. This entire carrier with all roller pairs will be installed later on in the valley station in Testa Grigia.
In the background, we can see the valley station being pre-assembled. We pre-assemble the entire valley station to prevent surprises on site when parts don't fit together. At these altitudes, making changes would be very complicated. It turned out that, of course, it's much easier to build something in warm and dry conditions with all the machinery at hand than at high altitude. At an altitude of 3,500 meters, where the air is thin, of course, there's not much wriggle room, and you're exposed to the elements. The only thing missing here is the concrete. The concrete foundation is poured on site.
Ever since construction began, there have been 30 to 35 workers on average working at the site every day. Concrete is poured into the foundations. As with every construction site, reinforcement had to be put in place first for the concrete construction, which is no problem if the sun is shining. One thing beyond their control, however, and rapidly changing: the weather. The biggest enemy up here. The team prepares inside the construction site before heading out into the icy cold. Here on the mountain, conditions can change abruptly. Roped up and secured, they make their way to the construction crane. A bad weather front is moving in.
If it's snowing but not too windy, we just keep on working. Or we always have a few spare jobs left to do inside, so people can work where it's warmer. Sometimes there's no alternative, and we have to keep working whether it's snowing or not.
Time and again, frosty temperatures and changes in the weather make work difficult. The weather forecast doesn't look good. The crane must be able to turn freely on its own axis in strong winds. Otherwise, it might crash into the rocks.
The snow has to be gone, the drum has to be clean, all the rollers have to be clean. He has to check the overload protection system every day, whether the rollers are working, whether they're frozen, and all the bolts and screws on the boom. A visual inspection to see if one is loose. That has to be done every day.
A quick look down. Here, every move has to be just right, despite the safety equipment. The altitude doesn't make the job any easier, and up here, concentration and performance are significantly reduced. So double safety equipment is essential. The team works hand in hand without speaking much as they brave the stormy weather. Construction projects of this scale under weather conditions like these are not under the same time pressures as normal construction sites. But the deadline is approaching here too.
The weather forecast isn't good, so you omit the sub-reinforcement, and if there's snow the next day, you can clear it much better and do the reinforcement when the weather improves. To keep things from getting snowed under, because it always turns to ice that you can't get rid of. And with various pieces of timber formwork inside, you can't always heat everything with a gas flame. That could cause a fire.
Mother Nature mercilessly dumps fresh snow onto the construction site. This means shoveling over and over again. Assembly manager Florian Niederegger knows all about it. He's on the extreme construction site every day.
The biggest challenge is the altitude. We're at 3,880 meters here, roughly. So you have to work a little slower. And you have to look after yourself because everything is more strenuous, including the weather. The weather can change 6 times a day here. It gets hot, then there's wind, then snow. If you're unlucky, it changes every hour here.
With an anxious look at the sky, the work continues. Progress on the first tower is painstaking in poor weather. The wind whistles mercilessly. The cargo basket precariously rocks back and forth in the snow as crew members stubbornly fight their way forward. The large threaded bolts on the towers are locked and tightened. If there is no alternative, work continues in sheltered areas. The existing metal struts are installed as the weather outside continues to deteriorate. Replenishments of supplies grind to a halt.
It really hampers our work because we can't bring up any more material. Now we just have to see if we can make it through the afternoon. And the weather forecast says it'll be better tomorrow. So then we'll be able to get the next parts up. Today we have to keep everything clear of snow so we can do our work properly tomorrow.
Work remains a waiting game. The pressure for completion by the planned opening is growing by the day. A location change to the headquarters of Fatzabruck on Lake Constance. This is where the special cables, the track cables and the hauling cables for the Alpine crossing cable car on Klein Matterhorn are made. Each cable consists of several wires. Once they're delivered, the wire coils first undergo a material inspection. There is no tolerance for faults here. No wire can skip a trip to the test lab. This is where the individual wires are tested for resilience.
The wire is cut from the coil and sent to us for tensile testing. This is a 10-ton tensile testing machine that we use to test the wire strength.
The wire breaks at more than 10 tons of tension. But that's not all.
We do a tensile test like the one back here. We have a bending test where the wire is clamped and rotated 90 degrees. It has to reach a certain number depending on the strength. In the torsion testing machine, the wires are twisted until they break.
The wire is put through the wringer. Human lives will literally hang from these ropes later on, so they have to meet the very highest quality standards. If it passes the test, it continues on to the cable drum. This is very strong, high-quality carbon steel, rolled down to the required diameter and strength. The raw material is produced almost exclusively in Germany. FATSA's machinery is specially designed and adapted for the production of these cable types. The factory on Lake Constance is highly specialized.
Once our test lab has approved the wires, they're placed on the cable drums and rewound onto the corresponding machine spools. With a certain tension and a clean wrap, that prevents wire breaks in production afterwards.
The supplied wire must be rewound from the wire spools onto the machine spools with low tension. This requires manual work while the spool is turning. The machine then rewinds the wire for the subsequent strand production.
This is the rear part of the machine. Here we see the core wire. The core wire is in the middle of a strand or spiral rope. The whole structure actually surrounds the core wire afterwards.
Each element of the cable consists of a construction of wires helically twisted in the same direction in several layers around the core wire.
So this is where the strand is created with the core wire that we saw earlier at the end of the machine. Here, the individual wires are processed into a strand with the appropriate greasing. The strand is stripped, possibly also blown, to give it the right properties for further processing into a stranded rope.
After the first production step, the strand is aligned on the strand straightener. During production, the strand is cleaned at the so-called stripper.
A strand is a structure consisting of different wires, rounded with several layers or different numbers of wires in different strengths, braided to create a strand. It's actually like a simple spiral rope, and of course it can also be used individually as simple auxiliary ropes, as simple pull ropes, but in this case it's used to produce a stranded rope with 6 strands.
Later on, the gondolas of the Matterhorn cableway will be suspended from this stranded cable, a custom-made product. Back at the construction site on Klein Matterhorn. Florian Niederegger opens his blueprint to check the tasks for the day ahead. There is a numbered sketch for each component.
Each individual component is labeled with a number, and we can use this number when we look at the blueprint. We use it to determine which part goes where, one by one. So we have a number on each part, and then we have a list here, and we have all the drawing numbers on it, and then we look for the drawing.
Working by hand on one of the highest construction sites in Europe, and for good reason.
I also have the drawings on the computer, so everything is available in digital form too. You could work like that, but at this altitude, with the cold and everything, technology doesn't always work so well. With the paper, you're covered. It can snow, storm, anything. It still works. With the computer, when I'm out there, I could toss it after half an hour because it doesn't work anymore. That's why we have this version. So anyone can go in and have a look. Otherwise, I just have to keep opening up the drawings. In these conditions, it works better for me.
The cableway's first turntable is in sight and needs to be set in place. A job that requires an incredibly subtle touch. Now, everything has to fit perfectly to position the turntable in the mounting with centimeter precision.
The tricky moment is actually when we pull the turntable up from below and into the mounting. Everything has to fit together well, because the last 10 centimeters are in the mounting, and if they get stuck, we have a problem.
Centimeter by centimeter, the cableway turntable is lifted to fit it exactly into the prefabricated mounting. One critical moment, one mistake here, and the timetable comes to a standstill. A few more quick taps with the hammer, and it's a perfect fit.
Problem is, when you pull up the turntable, when it goes into the mounting, it gets heavier. You have to pull with several tons of force. You could use a crane, but that is usually far away. You're always working at limit, most of the time.
Working at the limit on one of the most spectacular construction sites in Switzerland. A cable winch hoists the drive pulley wheel to a height of 3,880 meters before slowly lowering it from the crane onto the support. Balancing the pulley wheel takes time. The tension is rising. Florian Niederecker's team has to press this monster into position in a very tight space. Slowly, very slowly, the giant slips into the right position.
The problem up here is that there's little space next to the two pulley wheels, and the ropeway runs over them, down the middle, so we have to be sure to bring the two drive pulley wheels up here and use the crane to get them into position.
Bit by bit, the drive pulley wheel is lowered into place. Florian Niederecker supervises the process with great concentration. This is a critical moment, because now everything has to fit. Once in place, it will mark another milestone.
You know, it's like Lego or Playmobil for adults. You have all these different components. Yeah, it's actually like a kind of Lego. That's what I'd compare it to, in terms of the workflow.
Back at the Fatzabruck factory on Lake Constance. Here, the finished stranded cable for the Matterhorn cableway runs from the production line onto a carrier drum.
A tailor-made product. Basically, we're a manufacturer. Every rope is made to the exact length and the exact diameter, or not, and in the end, it always has to meet the safety standards. At the end of the day, every rope is torn on a test stand to check whether the minimum compressive force has been met. This is usually easily met, but it has to be right.
In Fazza's in-house testing facility, the finished stranded cable is clamped into this machine to stretch it beyond its absolute load limit and cause it to break. For safety reasons, the tearing test takes place under this cage grid to prevent injury due to pieces of cable flying around. The machine slowly accelerates. Until it goes bang. This is how the test looks from another perspective. By the way, the camera survived, but not the stranded cable.
This rope has reached the minimum braking strength. It's reached 279 tons, the equivalent of 10 semi-trucks.
The cable is also tested on its own turnaround track to see how it performs on the rollers and drive pulley wheels.
The life cycle depends on how heavily it's used. We always speak of bending cycles, which is roughly the mileage of a car. A conventional cable reaches around 1 million bending cycles, depending on use. It can be more if it's used very intensively. If it's used less, it can be less. That also depends on the topography of the system. All in all, there are lots of factors that play a role in how long a cable lasts, and one of them is maintenance, of course.
Fazza also installs this little monitoring system as standard.
This is our TrueScan, which we can use to constantly monitor the condition of the cable and access the device externally. No matter where in the world TrueScan is installed, we always know the condition the cable is in.
The cable is ready to deliver. Work is still in full swing at an altitude of more than 3,800 meters. The final components are being installed on the only 2 towers. The time pressure is growing. The delivery deadline is relentlessly approaching. A construction crane hoists large components onto the top of the tower, where workers secure them in place. The scenery is breathtaking. The equipment for the 2 suspension cables and the hauling cable have already been completed. One cable alone weighs nearly 23 tons.
Naturally, the weight is critical. You have to bridge the gap. You have to pull the rope up the mountain. So first, you check whether the rope can be transported. Only then can you complete the project.
The team gets ready to roll out the suspension cable. Centimeter by centimeter toward the mountain station.
A suspension rope is a static rope. It doesn't move. It moves a little bit on the supports, but it's not made to be pulled around a pulley wheel. A suspension rope, on the other hand, is nice and round, nice and smooth for maximum comfort in the gondolas. A suspension rope is like a round rail, nothing else.
The suspension cable is pulled into the mountain station in a step also known as milking. The cable ends are spliced to guarantee a closed circuit free of knots. With this splicing technique, individual wires are cut open and interwoven or spliced with the other end. This creates a flawless circuit for a smooth gondola ride. The extreme temperatures up here are no problem for the cables. They are altitude and weather tested, and everything has been factored into the wire strength.
So if one wire breaks, there are still lots of other wires. And the tensile strength of a rope, you're working with wires up to 200 kilograms per square millimeter. You'll hardly find anything with a higher tensile strength than a rope. And that's why a rope is vastly superior to a chain.
Work with the cable hoists is going smoothly. Meter by meter, the fitters pull the cables onto the turnaround track. Any surprises at this stage would throw them off schedule. With the installation of the tri-cable gondola system, the workers prepare for the next step in the construction project, delivering and installing the gondolas on the Matterhorn Alpine Crossing cableway. The Super Puma, flown by Heli Swiss International, gently touches down on an Italian mountain road in the middle of the Cervinia ski resort. The new gondolas for the Matterhorn cableway will continue their ascent by helicopter from here. Heli Swiss flies up to 500 transport, firefighting, or assembly missions every year. Pilot Martin Paya checks the route and wind conditions before takeoff. The team prepares the gondolas for transport to the Testa Grigia Valley Station at an altitude of around 3,400 meters.
The gondolas weigh around 2,400 kilograms. It's slowly getting warmer, and the engine has its limits. This engine, this is a Super Puma, it can lift 4.5 tons at sea level at 15 degrees Celsius. And the higher you go, or the warmer it is, the less you can lift.
Martin Paya starts the Super Puma and slowly ascends. The suspension cable for the individual gondola cabins dangles below him. For the well-rehearsed team, this is routine. Catch the carabiner, attach the gondola, and take off. The first gondola makes its way to its future location at an altitude of more than 3,000 meters. The gondola is suspended 30 meters below the Super Puma.
We don't do anything dangerous. Otherwise, we'd have to stop beforehand. We're responsible for safety, and it's a tricky deployment. There's always something you've never experienced before. 100 cableway sites, each with its own pitfalls and properties.
Under the overcast cloud cover, everything goes according to plan. After a 7-minute flight, the pilot gently sets the first gondola down at its destination below the Testa Grigia Valley Station. There are no timeouts down in the valley either. The team is already preparing the next gondola cabin to be ferried up the mountainside. The Super Puma hovers and flies off again once the next load has been hooked in place. Everything has to be carefully planned to ensure that the deliveries run smoothly and safely.
So now it's safe. The cableways are adjusted in place. If the cableways were running, I wouldn't be allowed to fly over them for safety reasons. It's the cables and the cableways I have to look out for. But we have aerial obstacle maps where we can see where we need to fly and where the cableways run, because they're our biggest enemy.
Viewed from the air, the gondola looks tiny, but there are 2.5 tons of weight being moved here. Precision is essential when setting it down to keep the heavy load from swinging and becoming a hazard to the men on the ground. Unwrapped for the first time. There it is, the new gondola for the Matterhorn Alpine crossing. Martin Paya lands the Super Puma down on the mountain road in the valley to refuel. This dependable worker bee has a tank capacity of 2,000 liters.
It's great to fly. You can feel the engine, it responds quickly. It's agile and good-natured. Those are its characteristics.
The crew uses the short pit stop to ready the next gondola for transport. Together with his team, the pilot lifts the Super Puma back up to an altitude of 30 meters to safely fly the next gondola to its destination. This is how all the gondola cabins make it to their staging area, below the Testa Grigia Valley Station. For Martin Paya and his crew, now it's time to pack up and get ready for the next mission. Another milestone on the Matterhorn Glacier Ride 2 timetable has been reached. Mission accomplished. Time to take stock of progress.
Well, it couldn't have gone any better. Not too much sunshine and hardly any wind.
The new gondolas continue towards Testa Grigia, the valley station on the Italian side, and the final deployment location for the tri-cable ropeway.
We now also have a staging area here behind us where the gondolas are brought. Then we'll use the construction crane we have here on site to guide the gondolas onto the rope or assemble them. Then they'll be hooked into the rope and ready for operation.
The Pininfarina design gondolas are still missing the girder brackets for the cable. The crane slowly lowers them into place, where they are bolted to the gondola. The team readies the gondola for its marriage with the girder bracket. This is custom work too. The bolts are attached by hand. And tightened with a ratchet. Later, the upward journey will continue from here, up to Klein Matterhorn on the Swiss side. Once again, the crane hoists the gondola and girder bracket onto the tri-cable ropeway. Tri-cable ropeways have the highest technology and safety standards. Compared to conventional cableways, they have the advantage of being particularly stable and smooth running, even in strong winds. Once in use, the gondolas will be able to transport 28 passengers each, traveling safely and quickly over a height differential of 363 meters at a speed of 7.5 meters per second. The gondola is installed by lifting it directly onto the cable using a device to open the clamp.
This system is a tri-cable cableway, also known as a 3S. What's special about this system is that we have two track cables on which the vehicle rests with the guide rollers and a hauling cable to which the vehicle is clamped before it travels along the line.
When a gondola reaches a station, it's uncoupled from the hauling cable to reduce its speed. Inside the station, the cable car turns around on rollers, so passengers can climb aboard comfortably and slowly. The gondola floats into the station, its travel practically shutter-free.
With this system in particular, we can only have a maximum of 3 vehicles per side at any one time. So each vehicle has to be monitored at all times. The position it's in when one vehicle enters and the other vehicle exits.
Digital control and monitoring of the gondolas is important. The gondola roof has its own external power supply to provide backup power for the camera and intercom function within the gondola during a rescue. The capacitors can also quickly charge up as the gondola turns around in the station. Of course, another important aspect of the overall Matterhorn alpine crossing experience is the comfort of the gondolas themselves. The air suspension damping is checked for correct inflation to ensure that the ride will feel like a weightless glide.
The gondola comes to rest here at this position. It rests on this rail. There's a current collector on the gondola where the cabin draws the power to open the doors. Communicated by the photocell up here, which monitors the door positioning, so we can always be sure of whether they are open or closed.
Later, the drive will take just 4 minutes to cross the distance over the glacier. Everything is still in test and trial run mode to see whether the gondola runs cleanly into the station, stops where it's supposed to, and opens the doors automatically.
So the gondola advances to this position and the doors open after that. It then moves on to the other position where the seats are reheated, the vehicle is loaded, and then the door closes. Before the gondola can exit the station, the system checks to see whether the door is securely closed, so it's safely on the line and people can't open the door manually.
The view from the gondola as it departs the mountain station at 3,880 meters is exquisite. 2 of the 12 gondolas offer an added highlight. The Crystal Ride, a glass floor with a 360-degree view of the Matterhorn and the glacier.
When I'm riding it for the first time today, it's quiet, the panorama is spectacular, of course, but also the feeling of being in this gondola and getting from Klein Matterhorn to Testa Grigia in real comfort. It's a fantastic feeling.
The system runs perfectly. It climbs the mountain to the station at the top with ease and seemingly effortlessly. Following the opening of Matterhorn Glacier Ride 1 in the fall of 2018, Matterhorn Glacier Ride 2 is now about to complete the seamless link from Zermatt to Cervinia, Italy, a goal that dates back more than 80 years. But before this can become a reality, the system still has to be approved by the Swiss Federal Office of Transport. The day is approaching, and everyone involved is very tense. Urs Bürgi, in charge of electromechanical inspections and pictured here in the center, runs through various scenarios on the monitoring system and puts the entire system through its paces. Everything depends on this approval.
I would say it's like a motor vehicle test. It's the system. It's the vehicles that are being tested. It's not the people who are in focus here. Absolutely not. It's the system.
Nevertheless, the cableway staff must also be trained. The entire team needs to know what to do in the event of a malfunction. Every system has its own properties. The inspector has a very close eye on this too.
You always have to assume that if there's a real emergency, everyone will be nervous and nothing will be normal. And that's what makes practice so important.
The team at Matterhorn Cableways has its eyes on the prize. This specific case involves manually bleeding the brakes for test purposes. If air accumulates in the brake system, it impairs braking performance. A safety risk if the gondolas are full and braking performance is limited. The team members are nervous.
That's exactly how it should be.
Everything worked, right?
That's exactly how it has to go. It worked.
Final test passed. The model on the home stretch. Matterhorn Glacier Ride 2 from Klein Matterhorn to Testa Grigia. Today, it's reality. A few more slip covers removed, and it's all ready to go. Markus Siegrist is fascinated.
Blue skies, fresh snow on the glacier, and the ropeway is running. I'm overwhelmed. To me, it's just wonderful.
5 years of construction time. 60 million euros in construction costs. A project of gigantic proportions. A continuous year-round link between Switzerland and Italy is now finally in place. An extreme tightrope act in the Swiss Alps. at 3,883 meters above sea level. The highest cableway crossing in Europe.